All right, section 9, we're talking about medians. Now, medians, I copied this pretty picture here. The medians, a triangle has three different medians, right? And they're all these red lines in here. A median goes from a vertex, from one of the angles, to the opposite side, and it bisects the opposite side. It cuts that opposite side in half, right? So you see this orange side here, and it cuts these two in half. Or it cuts that one piece into two equal halves, right? Same thing happens with this other one, where we have this piece and the last one. So some things to know. A triangle median, the endpoints, we'll say one end comes out of the angle, one end touches an angle, or we could say vertex. And the other bisects the side opposite. Opposite the vertex. Right. So a median, one end touches, or it comes out of, or there's all kinds of different ways we can think about that. One end of it touches the vertex, or it touches the angle, it touches the point, and then it goes across the triangle and it bisects the opposite side, right? This angle here that I have highlighted, the opposite side would be this bottom one there, right? So that's a big piece that we can think about, right? If in the homework you're given A, and maybe this one's A and the other one's 5, you know that A has to be equal to 5, right? And you could say, well, the whole thing is 10. Now, so that's dealing with the sides of it. Some things to make sure that we know. The angles, this angle here and this angle there, are not necessarily bisected. We can't say that those two angles are equal. Something neat that we can say, this one's kind of weird to think about, is that say this length here, we're going to look at that length there and this length there. It's very obvious that the blue one is longer, but the question is how much longer is it? The blue one is going to be listed as like 2A, while the other one is just a plain old A. So that piece is 2 times as long as the other one, and we're going to actually use that piece of it in some of our problems. So, and that's the same for all 3 medians in the triangle, okay? So we could, if we wanted to, I might not draw the whole thing in, but this blue piece, we could call it B, and this piece here could be 2B, right? So the piece that comes out of the vertex, between the vertex, that angle, and the middle piece, that's 2A, whereas the piece that touches the side and then goes to the middle is A. All right, that's what we want to remember. Normally I don't think about the B's, and you could also draw C's in there, but I think it just makes the picture confusing. That's what we're going to need to remember. We're going to need to know the piece about the 2A and the A. So let's look at some of the problems and see what we can do. All right, find x if GF is 2x minus 4. So GF, that piece here is 2x minus 4. And VF is 2x minus 6. Well, we know that this piece and this piece are congruent, right? Because there's this median that comes out of here, and it splits that up into 2 congruent pieces. It bisects it. So I could say, well, the blue writing here, the 2x minus 4, has to be double 2x minus 6, right? This piece up here would also be 2x minus 6. So one way I could write this is I'd say, well, 2 double 2x minus 6 is equal to 2x minus 4. Right? This is the 2 times the half equals the whole. Right? That's one way to think about that, where this is the whole and these are the halves. So solving here, we're going to have, well, this will be 4x minus 12 is 2x minus 4. I'll add the 12 over. So this will give me 4x equals 2x plus negative 4 plus 12 gives me 8. I'll subtract 2x to the left, and I have, well, 2x is 8, and x is 4. All right, so that's the first piece. That's where I think a lot of your problems are going to end up falling in that category, that way of doing them. Now there's also number 3, and I think it's going to be a little bit different. We have KZ, that's this here, and I'm just going to outline it in black, and I'm going to underline that so we know which is what. And then we have ZD. ZD is going to be this piece there. Well, this doesn't actually deal with the sides of the triangles. It deals with the median and how it's cut in the middle of it, right? So we're actually going to use the piece with the 2A into the A. So how do we want to solve that? Well, we could say that, well, here we have 2A and A. We could think about this as being 2 times the small side, oops, is the long side, right? 2 times the small side is the long side. So the way that I'm going to write this in there is, this is the long side, and this is the small side. The small piece, the short piece. Here, I'll say short. That might be a better word. So 2 times the short is equal to the long. So 2 times the short, which is 1/2 x plus 2, is equal to the long, 2x minus 1. Yeah, there we are. This might be something that we want to write down. That would probably go along well with the part that I had up there with the A's. That might be a little bit easier to follow. So now whenever I distribute my 2 on the left, I'll have, well, this would be just a plain old x plus 4 is 2x minus 1. And I'm going to add my 1 to the left side, so I'll add 1. So this will turn into x plus 5 is 2x. And now I'm going to subtract an x from both sides. And this will end up being 5 equals x. And there we are. Now there's a way that we could check our work here. We could plug in to see how long these pieces are. So I'm going to do that. I'm going to plug into the long piece. The long piece, well, that's going to be 2 times 5 minus 1, which is going to be 9, right? 2 times 5 is 10, minus 1 is 9. Then the short will be 1/2 5 plus 2. Well, 1/2 of 5 is 2.5, plus 2 is going to be 4.5. So our short piece is 4.5, and our long piece is 9. And if you say, well, 4.5 is half of 9, so that works out. Our short piece has to be half the length of the long piece. So we can check our work that way. If we were to check our work in number 2, we'd plug back in, and they should be, well, we had the small piece and the long piece. The long piece should be double the length of the short piece, right? Always make sure you're looking at what what kind of sides do we have, right? Numbers 2 and number 3 dealt with different pieces of the triangle. They didn't deal with the same pieces. Let's look at number 4 and maybe it'll make a little bit more sense. So du is 4x minus 4, and ds is 3x. Well, that little blue line, the one that they drew in, not the one that I drew in, is a median. So that means that it cuts that opposite side in half. It bisects it. So the blue has to be equal to the black, right? These two pieces are equal. So I can say, well, 4x minus 4 is equal to 3x. So if I'll add my 4 over, so add 4. So this will be 4x is 3x plus 4. Subtracting 3x gives me x is 4. Now if I wanted to plug this back in to double check, I would get, well, I'll go ahead and plug it in. I'll take 4 times 4 minus 4, that's 12. And then 3 times 4 is 12. Well, so they are equal, which makes sense because we wanted them to be equal, so that's good. Right? Always make sure that you're reminding yourself, what are we supposed to be looking at, right? In number 4, we're looking at two pieces of a triangle that are equal, right? Two pieces that are equal. Number 5, find x if, that's kind of funny, if if right there is x, and then FL, this little piece down here, is 2x minus 6. Well, let's look back at our formula that I had up there. 2 times the short piece is equal to the long piece. Well, this is the short, and this is the long piece. So 2 times the short equals the long. So 2 times 2x minus 6 is x. And now we can just solve like normal. This will be 4x minus 12 is x. So I'll subtract my x to the left and I'll add my 12. This will give me 3x is 12 and x is 4. Now if I want to plug this back in to double check my answer, I'll say, well, if, well, that's just going to be 4, right? You just plug it in. Now FL will be 2 times 4 minus 6. So this would be 8 minus 6, which is 2. And that makes sense. FL is our short piece. It's 2. And our long piece is double that. It's 4. All right, moving on. Number 6. Find x if ik is that whole piece there, is x minus 3, while wk is 2x minus 9. Well, jw there, jw right there, that bisects that side, so we know that the blue piece is double the black piece. So I could say, well, x minus 3, that's the whole piece, is double the short piece, 2x minus 9. So solving this, I'll have, well, x minus 3 is equal to 4x minus 18. I'm going to add my 18 to the left, so this will be 15 equals 3x, and 5 is x. There we are. Number 7, find x if vk is this piece here, is x minus 3, and vj is 2x minus 12. Now here it should be relatively easy for us to see that those two pieces should be equal. Right? So I'll say, well, x minus 3 equals 2x minus 12. I'm going to add my 12 to the left. So here I'm going to add 12 to the left. That's going to give me x plus 9 is 2x. And then if I subtract my x, I get 9 is x. There we are. All right, 2 more problems. UT, that's that. NT is this piece here. From this, we should be able to see that the green piece is 2 times the length of the blue piece. So I'm going to write the green piece, x minus 5. That's going to be 2 times the blue piece, x minus 8. So whenever I solve here, I'll distribute my 2. So this will be x minus 5 is 2x minus 16. Now I'm going to subtract my x to the right side. So this will be negative 5 equals x minus 16. And now I'm going to add my 16 to the left, and I get 11 is x. There we are. Last problem. Find x if gn is that piece there. Then we have gt, which is the whole piece. Ooh. How would we go about that one? That one's kind of hard. Well, we know that this piece here, let's go back and think about our a's, how we had the a's. We have, this would be a, whereas this would be 2a. Altogether, we'd have how many a's total if we were to add those together? If we were to add them together, the whole thing would be 3 a's, right? It would be 2a plus a. So I'm just going to kind of think about this and write it out. We have, well, 3a is x minus 1. We know that, oh, excuse me, I wrote the wrong thing down. We're talking about the blue piece. This is going to be x plus 2. Sorry about that. Now we know that 2a is x minus 1, right? This is my green piece. This is my blue piece. Now, how should we go about this here? We want to relate them together. Well, let's divide them both to get our a's by themselves. Let's do that. So the top piece here, if we were to get our a by itself, it'd be a equals x plus 2 over 3. The bottom piece would turn into a equals x minus 1 over 2. Well, we know that a equals a, right? That's kind of nonsense. So then we can write in x plus 2 over 3 is x minus 1 over 2, right? Because they're both equal to a. Now we just have to solve. Now I get that this problem might be a little bit crazy. It might be a little bit difficult. I'm going to try to make sure that we don't have one like this on the homework. But it is kind of a neat idea. From here, we go about solving, and I'm going to multiply by the denominators. I'm going to multiply by 2 and 3. So right together they make 6. And the reason that I'm going to do that is because if I multiply by 6 on both sides, my fractions are going to go away. And I know that we don't really like fractions that much. My 6 and my 3 would cancel to be a 2. So on the left here, I'm going to have 2 and then x plus 2. Then on the right, my 6 and my 2 would cancel to be a 3. So this will be 3 x minus 1. Now we'll have 2x plus 4 and 3x minus 3. Now we're just solving like normal. I'll subtract my 2x to the right, and that'll be a plain old x. And on the left, I'll add my 3. That'll be 4, 5, 6, 7. So there we are. Now again, number 9 is the hardest problem, I think, at least on the paper. I'm going to try to make sure that we don't have one like that on our homework. But make sure that we know these rules here. The side opposite gets bisected here. And remember the piece with the A and the 2A, or you could think about it as 2 times the short leg. Think about down here, 2 times the short leg is equal to that long leg. All right, that's all.